We are live now. My name's Dan Forbes, and I'm here with our presenter today, Bryan, and we're just taking a second to talk about what a long day it's been for us. Bryan is in Auckland, New Zealand, and I'm here on the other side of the world in Southern California. And so my first presentation was at 4 o'clock this morning, and now Bryan is about the same time there in New Zealand. So I think I'll just kind of give you like a bit of an extended introduction, Bryan, as we wait for people to kind of slowly stream in from the last chat. I'm still awake. I know that's what Bryan and I were just talking about. So I'm really happy to see everyone here. I hope that after the workshop or the conference so far, you're like kind of excited to get started building with Substrate, and especially building runtimes with Frame. That's what we're here to talk about today. I showed that little slide of kind of a palette slotting down into a runtime, and there was the configuration interface and events and errors and storage, and so now we're going to bring that all to life. Actually, Bryan's going to bring that all to life. This workshop is me and Bryan, but really it's just Bryan, and I'm just here to introduce him. So without further ado, let me go ahead and get into that. From my point of view, Bryan is like a developer advocate's dream. People describe Substrate as like a playground for developers. And if you think of Substrate as a playground, then Bryan's like an Olympic gymnast, like somersaulting through the playground. So Bryan is not only the CTO of Acala and Laminar. I see some people like giving you love already there, and Bryan's going to explain more about what those two organizations are and how they relate to one another. But from my point of view, Bryan is like someone who's reached this next level pinnacle of open source contribution, where he's not only building on our open source framework, he's actually contributing back to it. And so if you read the rundown on Substrate 2.0 that came out recently, Bryan implemented our bounty protocol that's part of the core Kusama runtime now, and the first bounty on Kusama just went live earlier today, so that's really exciting. And Bryan also wrote the open runtime module library, which is a set of palettes that are not part of the core Frame palettes, but these are like these community palettes, which Gav talked about. And I think the ORML palettes are kind of some of the coolest palettes out there. So I hope I've talked Bryan up enough. I hope you're all really excited to hear his take on not just kind of like the steps of building a runtime, but maybe Bryan's idea of the right way to do those steps. And I think Bryan probably has a really good thought there. So without any further ado, Bryan, I'm going to drop my camera. I'll be around to answer questions and stuff, but the floor is yours. Have fun.
Yeah, thanks, Dan, for the intro. So you guys should be able to see the slides fine?
Yes. Yep,
cool.
Looks
nice.
Great.
Yeah. So just for the intro. So yeah, I'm the co-founder and CTO of Laminar, and also co-founder of Acala. So I'm also a Polkadot ambassador and Substrate contributor. So previously I've been teaching Substrate courses. So also we're planning to launch a new Substrate courses hopefully by end of this year. Yeah, so many people were asking what was the relation between Laminar and Acala, and there's the confusions in the community. So a quick story is basically where at Laminar previously at Laminar we build a synthetic assets and a margin trading protocol. So we have a proof of concept working on Ethereum, but we obviously want to build all that on Polkadot, because why not? It is probably the best blockchain platform we have currently. So we want to build the Laminar protocol on a Polkadot ecosystem, but what's the missing pieces by the time is we need a stable coin. There wasn't any stable coin project yet. So we need to either build it ourselves or find a team that is also want to build a stable coin, maybe build together, instead of having different teams building their own stable coin and competing with each other. So we meet the team from the Polka Wallets in Shanghai. Yes, so that's what, and then we found out we each other share the similar visions and the views of the Web3 decentralized world. So that's why we have both the Lambda team and the Polka Wallet team co-found the Acala Foundation together, and we build this Acala this project together. So enough for the intro. So this let me start with the agenda of this workshop. So it will start with me building a simple order book-based exchange. So we'll be design this palette. We'll talk about how do we design the palette from scratch, and we'll actually do some coding to implement this palette. So during this implementation, I'll be talking through about the Open Runtime module library, the open source library we've developed. I'm also going to share a bunch of tricks and tips for writing a high quality and high performance frame runtimes. So there are a lot of things that you probably only know if you write it. There are a lot of hidden tricks. It's very hard to learn unless you actually fall into the tricks for once. So those are the knowledge that I will share to everyone to help everyone to write a better frame runtimes. So, and last but not least, I will provide a walkthrough of how the ORML is being used by Acala by walking through the code of the Acala and give you guys some examples how they are being used and how they can be used. So let's start with a quick demo of the exchange palette that we are going to build. So I have running this node just a few minutes ago. So it offers a simple exchange palette. So it also offers a multi-currency. So I can check the balance of the LS account. So you can see I have 10 dots and 10 BTC here. So the unit is always I have defined the test unit because the Polka apps currently doesn't handle multiple currencies very well. So if you see this thing, this means it's one unit. So I have also both account have the same 10 dots and 10 BTC. So I want to make create using the exchange palette. So this function called submit order. So I can say maybe I want to using 10 dots exchange for 2 Bitcoin, a fair price. So we can submit a transaction, submit this order. When it's being executed on the event, you can see this is being created. And in the chain state, that you see that is a new order with this information, and a different user will be able to take this order so that it is 0. So I can just execute this. So LS is the order maker and the Bob is the taker. And when it's executed, I can check this. So the order is being executed, and just see the balance of LS and Bob. So so Bob now have 20 dots and 8 Bitcoin. So 10 more dots, 2 less Bitcoin, and the LS, as you may guess, have 10 less dots and 2 more Bitcoin. So the trade is being made by both parties. So that essentially this is a very, very basic order book. It doesn't have on-chain matching or off-chain, but matching can be done in off-chain side. In the later version, for example, we're using off-chain workers to do matching. So yep, this is what we're going to build. So let's start with the palette design. So how do we design this? So when you design palette, it's probably easier to start with the cores or the extrinsics that you're going to offer to the people. They are basically the external functionality that people can invoke by sending a transaction. So as you may guess, we're going to have a submit order function that takes those parameters like base currency ID, the currency I'm going to offer, and how much I'm going to offer, how much I want to take, the currency I want to take, and how much I want to take. So in the example, there will be the currency, base currency that will be dot, and there will be 10 dot, and I'm asking for Bitcoin, then I'm asking for 2 Bitcoin. So that's how you create the order. And as a counterparty, they can basically take order by providing an order ID. And the order ID which can be obtained get from the events emitted by the submit order. And there's also a cancel order. So if for whatever reason I don't want to make the trade anymore, so I can just cancel the order. So this is basically the external interface for users to interact with this palette. The next thing will be the types. So obviously we will have some like custom data structure to store to relate things together. So we have a struct order that is like the same as the input parameter with additional field, the owner. So the people who the owner of the order. So only the owner can cancel the order. And if someone is taking the order, they will trade with the owner. So that's the customer type we have. And next will be the storage. Storage are the things that how the data stored in the blockchain state. So it's also easy. We will have orders that store basically all the orders, and it's a map indexed by order ID. So you can query all the orders just by a given ID. And there's the next order ID that is to be used when you create a new order. You'll use this to calculate the next order ID. And there are also events. Events are used so for the SDKs or the blockchain clients, like for example the wallets, exchange, etc., to listen on the events on the blockchain to understand what is going on. So it's also very simple. Basically, have one event for each action the user can make. So it's order created with the ID and the order itself, order taken, who takes the order, the ID and order itself, and when the order is cancelled. So the front end or wallets, they can know what's going on without actually reading the blockchain state or monitor the blockchain state. They can just monitor the events. So put everything together, that is the design for the simple exchange palette. Before writing code, is probably always almost you should have something similar to this, so you know exactly what you're going to write. Cool. So this, before actually start writing the code, there's another thing that I'm going to talk about is the support of multiple currencies. Because in the node templates or in the substrate frame core palettes, it provides ability to deal with one currency very well, but there are no very good way to deal with multiple currencies. So there are a few options available. So the first option is having multiple instances of the palette balances. So in the substrate, it's possible to have multiple instances of most of the palettes as long as they support it. But there are limitations. The firstly is this is confirmed at compile time, or basically you need to write code to modify or add a new instance. So you cannot just call transition to add a new one. You need to actually modify the code, compile it, generate a new runtime, upgrade a runtime, then you get a new instance. And it also supports limited number of instances, which means limited number of assets. So for example, if you want to build an exchange supports like all the tokens, this is probably not the best way to go, because due to the limitation, you can probably, as far as I can remember, you can only have up to 16 different instances. So another option would be using the core assets palette from the frame. So it provides a basic asset management features, like for example, create a new asset, issue a mint. But currently, it doesn't play well with other palettes. For example, you cannot use assets and have it work with treasury directly without writing additional code. And right now, it is also not production ready, which means that, for example, it doesn't have the benchmarking and weights. So it will be a security issue. The code, at least right now, is not fully audited. So you need to think twice before include this into a production code. The upside is there is a work in progress pull request to improve it. So Gavin is working on this reserve back features on the assets, which will add a lot more features and level it up into actually production ready by adding the benchmarking and weights. So previously, there's another options as well, so which is the generic assets palette in the frames code. It's more feature complete than the assets palette. It also implements the currency tree, which means it's able to work with other palettes that are expecting a currency tree. For example, you can use the general assets with the treasury or with the staking palettes together. But unfortunately, it is also not production ready. Similar to the assets palette, it doesn't have the proper ways of benchmarking. It's not fully audited. It also has many features, but not necessarily required by everyone. So some people maybe don't want people to create a new assets. So you cannot disable them with the actually modified code currently. So that's why it's being removed from the Sub0 version 2.0. So people should using other options instead of using the general assets. So, so next option will be using the palettes provided by the ORML, the Open Runtime Module Library. So we have the tokens palettes and the currencies palette. So that's the URL. This is the open source project developed and maintained by the Lambda Acala developers. So it's also being used by Lambda Acala itself and also a few other projects as well. So we have implemented a multi-currency trade abstraction, which is very similar to the currency trade provided by Foreign Core, but it's actually provide native support of multiple currencies. And the core design concept of the ORML is they are all minimum by default, so it doesn't provide unnecessary features, but it's super easy to extend it. So if you want, for example, ability to create a new asset, you can easily write few lines code to have that. But by default, it doesn't provide the features to add a new asset. So currently it's under auditing. So we also have all the weights and benchmarking written for those. So they should be in production ready when it needs to be, because obviously we're going to use those code in our production production when they are launching. So let me talk about more details about each individual palettes. So for the tokens palettes, it implements is similar to the assets palettes, implements the multi-assets in a single palette. So it doesn't have all the, it only provides the core features. So like transfer, there's basically only core features, which is a transfer asset. So you won't be able to create a new asset, but if you train who need this feature, it's super easy to extend it. So we also have adapters to make compatible with Frank's core traits like currency. So you can use the tokens work with like treasury or staking or any other palettes they are using as currency trade. So the currency trade is this maybe some confusion. So because we have tokens, then what's the point of the currency? So currency trade is the glue code between the balance palette and the tokens palette. The reason we want to keep using the balance palette is mainly for the existing tools integration. So for example, the Polkadot apps and the Subscan, Polkascan, etc., they all support the balance palettes very well, able to raise and index in the event, etc. So we don't want to, we still want to keep this capability with all the existing tools. So we still would like to use the balance palette. And balance palette itself is also better optimized as well. So for example, the storage, they are actually stored in the system palettes along with the countdowns and other related information. So it is much more performant. So in Acala, we're using both the palette balances and ORML tokens at the same time. But it will be quite trouble if like in every single code that deal with tokens, we need to check if the token is ACA, we need to use in the palette balance. If the token is something else, we're using ORML tokens. That would be just too hard to maintain the code. So that's why we have the ORML currencies. So basically, we can using the tokens to manage all the other assets and still using the palette balances to deal with the native asset. Cool. So this is enough talking this HA start implements this new exchange palette. So we'll start from the node template. So you can just use this template and create a new project to get started. And next thing will be just the first step will be adding the ORML palettes, like adding the currencies and tokens, etc. So the start is so this is the brand new newly created the template file. So we want to add the new palettes into the ORML, the new ORML palettes. They are all published on the create style, so you can just use them. You can just add them. So we'll be here. So it's basically similar to adding other substrate palettes. And then the next thing will be just actually use them in a runtime. So we'll be adding a bunch of traits implementation. So first is the tokens. So in the docs Rust, you can see the documents for all these palettes. So you can go to see the treats section or more here. So the treats. So you can see, use this one to see what other types are required to implement this trait, or it's probably sometimes easier just read the source code on the ORML to know exactly what they are expecting. So in here, it's quite simple. Then we just have events, the balance type, the amount type is something. The amount type is basically the signed version of the balance type, which we will need to define ourselves. So the balance type is U128 in this case, so the signed version will be I128. We also need to define the currency ID. So this can be anything. So for example, it can be just so it's just easy use a digital currency ID. And then if you people want to implement a currency ID, add a new currency ID, they can do that. This could also be something like, or maybe so there will be something similar to like Ethereum, where the ERC20, the smart contract address will be used as a currency ID. So in our case, we will be using an enum for currency ID. So this means it's easier to deal with this in the Rust code. Also, in the front end, this provides a nice feature there because we have list all the available options in the enum. So the front end, you can generate a nice drop down to allow user to select the currency ID instead of like otherwise. If you want to enter Bitcoin, you need to know this is number 3 instead of just using BTC. There are a bunch of derives which should implement. So we need the serialized, deserialized. They are needed for the RPC and also for the Genesis generation. The encode decode is just a standard one, equal, partial equal, clone copy. They just all these are just a standard derives. And obviously, we need to have bunch use to be able to actually make compile. So that is basically the configuration for the tokens. And the next thing will be the configuration for the currencies. So we still have the events. So the multi-currency implementation will be using the tokens as the multi-currency implementation. So the native currency implementation will be using the balance palettes because the native currency type is expecting a trade from the ORML trades. So the balance itself doesn't implement the trade. That's why we need an adapter to implement the trade. So we'll also need a use for that, using the basic currency adapter from ORML currencies. So this will make the balance palette implement the trade. Or it can be any other balance that implements a currency trade. You can use the adapter to convert it. So you don't necessarily need to use the balance palette. We also need to tell the currency trade that what is the native currency. So when doing with the native currency, if we're using the native currency to do the transfer, make deposit, etc., and when the other currency using the multi-currency implementation, they will tell we define the native currency. In this case, is the native one. And so this is basically a runtime configuration, and then we just need to add this to the runtime tree. So you see that I've omitted the calls in the ORML tokens because the user shouldn't really need to using the tokens call to integrate with the palettes. They should be using the currencies one. So so the call is omitted here. So that is basically how you add the ORML tokens and currencies. So another thing you want to do is to convert the transfer, because the token is expecting a transfer. So in here we can add some types here. So we just use the token convert to generate from the construct right now. And in the transfer here, we'll just need to convert it. So basically, the genesis convert expected in those accounts, which is similar to the balances. So in this case, it will be just used for those accounts. Every account that will have this many of BTC and dots. So by default, the decimal place on Sub0 node template is 15 decimals. So that means that each account will have 10 dots and 10 Bitcoin from the genesis. Another thing that is usually helpful is provide some additional genesis properties to tell the front end SDK itself the decimal place of the snap. So what we can do is different convert graders properties. So based on that, so we'll need to use this the 30 JSON, and also need to add this into the cargo file. So by doing this, we need to pass this to the properties. So by doing this, the runtime will be able to, the SDK, the client, the Polkadot.js will be able to read this from the Genesis file or using RPC. So they will see the token symbol. In this case, is defined as test, and the token decimal is 15. So we know how to format the balance type to display it properly. So with this being done, then we will basically have all the tokens set up. So you will have an account with multiple Genesis balance, which is useful for testing purpose. But obviously, for the mainnet, you probably need to make sure they shouldn't have all the airdrop tokens if they're not supposed to have. So then the next step will be actually implement the palette exchange. So one thing we can do is just copy paste the template palette and use it as a starting point. But I'm going to just start from the scratch. So creating the file. So there's a cargo.com file. So I'm trying to keep this minimal, just only keep all the necessary things. So you will start with if code is always needed, frame support and frame assistance always needed. But those are all the required dependencies. Obviously, if you want to implement more features, you will need other dependencies as well. order. So let's start with very minimum code to have a proper palettes. So it's very simple. So this one you always need this one. Otherwise, you have some mysterious compile error. Then we're just using a bunch of the macros from the frame support. Define a trait. You always need to have this. You usually want to have this if you have any events. If you don't have events, then you don't need to define the event type. Then define the storage, define the event, define the error, define the module, which is type error and decode the event. So that's pretty much a full complete palette without any features or functionalities, but it's a full palette. And the next thing will be adding this palette into our runtime. So go to runtime, color file, just okay. And we also need this in the runtime source file. We also need to define the tree. So this is the simplest palettes you can have. Well, I guess it can be even simpler if you don't actually have storage for events, but this is basically simple, complete palettes you can have. So start with using this as starting point, then we can start actually writing the code. So first thing we want to implement is the submit order feature. So there are a bunch of the dependencies we need to have first. So I'm going to just quickly put all the used copy paste all the used first. And I need to also add some dependencies. So we're using the SP runtime for a bunch of related features from substrate, and also using the ORM treats for ORM. So let's start with the trade. So first thing we want is currency, because we are dealing with money. So we probably always just want the currency trade. So in this case, we'll be using the amount reserved for currency from all our metrics. So this one is very similar to the reserve for currency from the frame support. But obviously the main difference is this one supports multiple currency instead of just one currency. We also have defined the order ID type. So, this is something like kind of optional because you can simply hardcode the order ID type first. And obviously that should be hardcode, you cannot configure. But so it's purely a design decision. See if you actually want the runtime to decide the type, or you want the palette itself to decide the type. So this is drive by case by case. So if you're implementing a reusable palettes, then you probably want to allow the runtimes. You don't have to take the unnecessary decision, make the unnecessary decision for other people. But if this is not meant to be reused by other runtimes, then well, you're not going to change it. You might as well just define it here. To make things very simple. And the next thing is we want to have the order struct. So this is basically similar to the one we showed in the design. So the few things need to be kept in mind. So first we have using the codec compact here. This is optional. You don't need to have them. This is just additional optimizations to make the balance type to be compact when they are serialized or encoded. So this will basically make the reduce the transition size if the order is used in parameter, or when they're serialized in a state, they will be smaller. But this obviously is a trade-off because it will take more time to encode or decode the thing. So it's also case by case. Sometimes you want to have compact encoding, sometimes you don't. But for balance type, you usually want to have compact encoding because by default it's quite large. It's 1 to 8 bits. But the amount is usually small because obvious. It also depends on how many decimal places your token have. It can be very small. Like for example, if your token only have 4 decimal places, then you're not expecting you're going to using the most significant I feel like 50 bits or something. So the company will usually always significant to save storage. And so there again is back derived. So what we have like the encode decoder just standard. They are required if you want to save in storage, if you want to pass them parameters. Clone just is equal partial equal to the standard thing. A runtime debug is a trait from a substrate that implements the debug, but during the version build, it will strip off all the unnecessary code. So the debug information will be much less, but because your production build, you want to trade off the code size for the less detailed information because they are available in the development build anyway. You really want to make sure your runtime is as small as possible. So this is the order tree, and we just have 3 generic parameters. So when you're using the thread, it will be a bit tedious. You need to type all the parts in 3 different types. So it's usually a good idea to have a bunch of type alias just to keep the code more readable and more compact. So you see we're using this tree doesn't define the balance type. Instead, we're using whatever the currency type, the balance defined by this currency type. So this is what this does. It's basically taking this currency, make sure the type is this one, and get a balance type. And similar for the currency ID type, it will be using whatever currency ID defined by this multi-reservable currency. So we can, if we want to, just have the balance type or currency type defined here, but there's no need to in this case. So with those, and then we can define order ID, order of T, which will be basically order passing the currency type, ID type, balance type, account ID type. So when you use refer to the struct, you only need to using order of T instead of just this whole thing. So this the next thing, because we already have the design, so it's super obvious for us that exactly what we're going to write in the store events and the module. So we can just start from the storage. So it's just same as the design. We're going to have orders using from order ID to the option order of T. So for a map, this doesn't need to be option, but it's usually a good idea to be option. If this is not option type, then we will need to make this implement default, direct default. So it will generate a default instance. It doesn't make sense to have a default instance in the case of order ID is invalid. So we should just use an option type here. And the hasher itself is something, again, this is case by case. In this case, the order ID is a serialized number generated by runtime itself. Is not an arbitrary user supply type, so it's safe to using the 2x to compare the fast version, but insecure if user is able to arbitrarily modify the order ID. And so we will also have the events. So just start with the order operator. So we're using the syntax to tell the macros what are the exact type of those. So there are 2 different ways to define the type. One is the type equal to some other type. One is this one. So this one is shortcut of this one. So they are exactly the same. This one is slightly less typing if we see something to cut us. We will also have an error, in that case, which is ID overflow. So we can now start the implementation of the create order or submit order. yeah, so this is just same as design. So the first step is usually always just get the signer, like the origin of this transition. Next thing what we want to do is basically read the next order ID incremented by 1 and use the current order ID as the order ID to create a new order. But you will see, because this is like there's a maximum value of the order ID, so it is possible if there's going to overflow. It's quite unlikely if you pass in the right type, but nevertheless, it's literally possible. So we need to handle the case if there's overflow as well if there's error. So there are different ways to do the next thing. So one way is basically read the next order ID increment by 1 and write it back. So you will have 2 access. There's another way to avoid multiple access is by just using the mutate or try mutate. So what try mutate does is, or mutate or try mutate does is like basically read the value, run the closure, and then which may or may not modify the ID. For the mutate, it cannot fail. For the try mutate case, it can fail. But so it will write back only if the success. If it fails, it won't actually write the storage back. So this will allow you to access this only once instead of twice, because there are some overhead of like compute the storage key of the storage. So you already see this already hasher function. So you need to hash this, and in this case, the hasher is the cheap one, so it doesn't really matter much. But it could be expensive if you're using a secure hasher. So in this case, we'll be using try mutate to keep things simple. And we'll read the order ID. So this is a reference, so we just do reference here. And create the order object. And we will increment the order ID by 1. So in this case, we're using check finesse to make sure this cannot overflow, to make sure overflow case is handled. So we'll add this by 1. And if this fails, it will return the order ID overflow error with this question mark, which will return early on error. So if this error, if this fails, this will return the error. And an error in return from this closure means this order ID will not be modified, and this will fail return this error as well, and which will trigger this question mark, which will return the main transaction. And then we can do is next thing will be reserve the money. So the interface of multi-currency is very similar to the currency, but it just have additional currency ID as the parameter. So you basically reserve this, so make sure the user actually do have this amount of money to pay, which will be unreserved when someone else is taking order. And then we can write the order at the storage and report the event. So that's basically the full implementation of the standard order. You see that in many Sub0 tutorials, there's one thing to keep in mind: is you shouldn't have two fail row mutation in a method together. But in this case, it's safe to do so because this is not a storage write. This storage write happens after this closure finishes. And then if only this write only will happen if the whole thing returns okay. If this errors out, this will not actually be a write, so this is safe. So then the next step will be in the runtime. So we will just add the additional types we have here. So we have the currency, we will pass in a currency type. So it will be able to deal with the native currency correctly. We're passing all the ID. In this case, will be user2. But this will be the configuration. If you want, we can let's configure 64. So next thing we want to implement is the take order feature. So let me start with a few more use as well. I will just copy paste everything. So this is the ensure we're going to use, the balance text we're going to use. Also, we're going to use the with transitional result, which is part of the ORM utilities, so, which I need to import here. And then we're going to also have order taken event, which will need the account ID type here. And we have two more errors we're going to make here. So then we can start implement our take order. So again, start with just get the signer of the transition. And in this case, next thing we'll also using the similar pattern. In this case, we'll be using the try mutate just instead of try mutate. So what the difference is try mutate will always assume the thing is going to exist. If it doesn't exist, it will get a default instance. But this one, the type of this is always optional. And this can be also used to delete a storage if you modify to the value of this optional to none. So this is also a very common patterns used a lot in our code base. It's basically just you can use try mutate this, and you can take the option out of it and check OK or all error. So this line does a lot of things. Okay? So first, it's going to delete the order. Obviously, only if the whole closure returns OK. If this errors out at any stage, nothing will be returned to orders. So this will delete orders, and it will check if the order actually exists. If it doesn't exist, it will return this error. So then we now have the order object, and we know this exists at that stage. So we can just execute the order. So by executing the order, we want to transfer the money from the current signer to the order owner. And the currency we want to transfer is the target currency ID the owner wants on the order, and the amount is the amount the owner wants. So this will fail if the who user does not have enough money. And next thing we'll need to do is basically unreserve the money we previously reserved here, and then transfer to this user. But this is this method available, so it will does unreserve and transfer in one go. So instead of two methods, we can just using one method. So the main difference between this and the transfer is this will transfer the reserved amount instead of the free amount. And this means after transfer, this will transfer into the free parts of the balance instead of transfer into the reserved part directly. But there's one catch to use this reserve method is that it returns the value is how much is not transferred. So for example, when you reserve 10 dots and then you try to reinterpret reserve 10 dots, it will success. But if for whatever reason the 10 dots previous reserve have been slashed or something, it's only 5 dots remaining, this is still going to success. But instead of telling you this 5 dots out transfer, but this is not what we want in this case because the other party will be taking a loss. So we need to ensure this value is 0, so the full amount is being transferred. That is basically the implementation for take order. But there's one catch here. Is as I mentioned before, multiple mutate is unsafe. So this could fail, this could fail. And if this success, so the money is payment is being paid, but this could fail or this could fail, then because we don't have any reverse building by Sub0 by default, so it will be one party takes money and the other party didn't take what they want. So this will be a security nightmare. So there are different ways to solve this issue. One way is basically check the free balance to make sure the switch is going to success and make sure this is going to success by making checks here. But that is but tedious. This is where, so in Sub0 2, there's a new feature called with transition. This with transition feature is able to let me see. So this with transition feature is allow you to pass in closure. It will execute this closure and then commit or reverse result depending on the return type. So you can choose to commit the storage write or you can roll back. So this allows the users to have full controls of how they're going to modify the storage. Like in this case, I want to roll back if any of those two fail. So I'll be using the with transition. But the with transition, expecting a transition outcome return type it's a bit hard to use. So that's why the ORML utility provides the with transition results, which is basically a wrapper of the with transition, but instead of expecting a transition outcome return type, it's expecting a dispatch error. So you can just using the question mark syntax to return early, and this will handles the converting into the transition outcome. So this is just the utility, but it's a nice to have utility function. So we'll be just put everything here into here. So with this, then this will be suddenly become a secure thing to do. So if this failed, this will see it should roll back the trends, which will roll back this transfer. So it guarantees either the transition is fully made or no transfer is being made. So yeah, this is the implementation of the take order. So the remaining part will be the cancel order. So first we just add a new event. We will have a new arrow is going to make. And you can stop this. In the cancel order, so this is going to use the same patterns we've used before, because this is so we're going to try mutate just the orders, try to remove it and return the error if the order is ID is invalid. We need to check if the owner of the order is the transition origin, just to make sure you cannot cancel other people's order. And lastly, we'll just depose the event at return OK. And after return OK, this try mutate this will actually remove the order. So yeah, so that is the whole implementation of this exchange palette. I guess, does anyone have any questions? Anything you want me to go through again, explain a bit more? Dan, do you have anything? So for the rest of time, I'll be just spend a bit more time explaining the ORML. So they all are being published on Chris.io, so you can just search ORML to find a bunch of palettes that are being developed. So some of them are the legacy palettes that were deleted, for example, the schedule update, in Sub0 2.0, there's the schedule from the core runtime, so this isn't any needs to have our own version of it. So we're just not updating this anymore. But otherwise, you will see there are a bunch of palettes available. You can using obviously the dos.is to find the documents and find the reference, but sometimes it's much easier to just read the source code of the palettes to understand what is going on. So this is the repo for Acala. So I'm just going to briefly describe all the palettes we have here. So with auction palettes, I think I should start with the trees, so which is probably the most commonly used one in ORML. So we define a bunch of different trees, like the auction trees, allow people to implement an auction. With the currency trades, which we have used before in the exchange. So with the multi-currency, which is basically the multi-version of the currency. It's a currency ID, so provide a similar feature. We have the extended one, which is the amount type, so you can update balance, which will be add or remove balance, depends on the size of the amount. That is quite handy in some use case. So with the local one and the reserve one, so basically local, basically reserve currency. So it implements the similar feature. So we also have the adapter, which will provide by the currency trade. So this provides adapter that implements all these palettes for the corresponding palettes on the provide by frame. So if you have any palettes implements the local one, then you can use adapter to make implements the basic local currency. So the basic currency is provided the same functionality of the corresponding party on the frame, but it's a much simpler implementation. It doesn't offer all the imbalance feature, which is imbalance is a super useful feature, but it's not always needed and can be pretty hard to implement the imbalance feature for some palettes. So that's why we have this basic version of it. We also have the data provider trace, which will be used. This is developed by us and the band protocol team. So they are doing an Oracle solution. So this allows us to support multiple Oracle providers. So like in Acala, we will be running some Oracle server ourselves, but we'll be inviting other Oracle solutions to run Oracle server for us. And this will allow us and all the dev developed on Acala to be able to choose which Oracle provider they're going to support. So there's much more tricks for other parts of the ORML palettes. So yes, so the auction basically implements the auction feature. So it handles the basic features by stores the auctions, and handles the index, handles the end time, allow user to submit a bid, and it's using. This is designed to be very extensible because a lot of logics can be defined by implements the auction handler, which defined in the trees. So you can choose what to do on a new bid. You can choose what to do on when auctions end, which could be like transfer money or transfer NFT or something. So we also have authority palettes. So this is basically our try on a governance model on Acala. So initially we'll start with more or less semi-decentralized way. Because a fully decentralization from day one is really, really hard. That's why we developed this authority. So it provides many two features. One is scheduled transaction requires certain things to be delayed. So that means like the time lock delay is quite a common feature on the Ethereum as well. So the admin key can do any changes, but it's always time locked, time delayed for, like, for example, 2 days. So during this 2-day period, the other people's can audit the change, and if they want, they can withdraw the money, just run away. If, like for example, admin is trying to steal all the money. So this implements a similar feature, requires certain options to be delayed. It also implements the features allow transaction to execute the code on behalf of another origin using this spec S. So the use case will be, for example, the console can, like more than 2/3 of console can dispatch as the root origin, so they can do runtime upgrade. But combined with the delayed feature, that means we can say something like more than 2/3 of console can run as root, but they need to wait for 7 days for the code to be executed. And during the 7 days, then we can have something like more than half of the console can cancel the delayed transactions, or the different or other token holders can choose to cancel the transactions to just make sure the console itself cannot just hijack the whole network. So with benchmarking, so you probably shouldn't use this one unless you're facing the exact compile error that we're facing. So we need to focus. The currencies, the gradual update is an interesting one. We're probably not going to use this in our production code, but again, it's something experimental things. As a DeFi project, Acala, with a lot of numeric parameters, like for example, the interest rate of the or the character ratios for the stable coin. We will want to modify those parameters, but we probably shouldn't modify all of them at once in one go. For example, if we want to raise the character ratios from 120% to 150%, if we just rise in one block, then there's a chance of a lot of character positions get liquidated in a single block, which will causing a lot of bad effects. So that's why we have this gradual update features that allow us to gradually modify over a period of maybe a week. So on a day one, there may be no changes. On a day two, there may be some very dangerous position get liquidated. But they won't be liquidated in just one single block. This will also allow us to cancel the updates. Like for example, if you raise the character ratios by 20%, but after 2 days, it's been raised by 5%, we believe the risk parameter is safe enough, then we can just cancel the update. So this allows for a lot of interesting experiments. But this is modifying the low-level storage directly. So it's a bit unsafe to use. It's almost like you modify your database file by a text editor, which is almost always unsafe. So we're probably not going to use this in production code. With a bunch of other things, NFT palettes, this provide again a minimum by default, absolutely minimum to implement NFT feature. We don't even have any cost available. So if you want to use NFT, you need to implement your own palettes to expose some cost, so to make this actually useful. So which you can use the NFT code of Acala as example. So in this case, we have in our different modules, we do have costs. So user will be transacting with using this module NFT instead of ORML NFT. So let's say a bunch of additional logics that only make sense. It doesn't make sense to live in ORML. That's why I do the thing, but the core functionality is using the ORML NFT to do the coursing. There are other things. So with Oracle palettes, so this is basically a proof of authority Oracle palettes allow the government. This what is designed to with the collective palettes from the frame runtime. So the membership data are stored in the collective palettes, and it's up to the collective palette to decide how the memberships are modified. So this makes no assumption how you're going to manage the permissions of feeding the runtime. This is another benefit of Sub0, so that it's so flexible that we don't need to make decisions in this palette. It's up to the runtime implementer to decide how they're going to manage the permission. So next thing will be rewards. So we have a bunch of incentive programs. Some are temporary, some are permanent. Some are paid by the profits of the network. Some are paid by the previously reserved tokens. But they're sharing a similar logics on disputing the rewards. So we have the palettes to abstract the shared logics. So if you want to have something similar, you can look at the incentive palettes of the usage of the thing. So you can see we have like different kind of incentives, and each of them they are all implemented. The low level thing are handled by the rewards palettes. Yes. So we also will be talking about tokens. So the utility we kind of go through utility. We have some data structure, some iterators to iterate storage in the runtime. We previously have a bunch of chain worker related code here, but almost often have been already contributed into a substrate directly, so we don't have too much here just anymore. And we also have our version of the vesting palette, which is very similar to the vesting palettes in the frame runtime, but using a slightly different vesting schedule implementation. So yeah, that is basically all the palettes we have in the ORML. And if you have any questions, or if you want to just see how they're being used, the best place would be just checking the source code of Acala repo. This will be a primary user of the ORML runtime.
Bryan, are you able to hear me?
Yes.
Okay, cool. I'm like, for some reason on my end, my screen is basically frozen. So it's very hard for me to interact with Crowdcast.
Okay.
But I'm glad that you're able to hear me. And clearly I wasn't wrong when I said that I was going to do little more than introduce you. If anyone was going to have their host just kind of like drop dead on them, I'm definitely glad it was you, because you handled that wonderfully. I don't really see any questions, and I think that is probably a testament to the strength of your workshop. So if you feel like you've kind of covered the high points that you want to cover, I think that we can, end the workshop a little bit early. We can wait for a few minutes to see if there are any questions coming in. Are there any maybe links that you want to share or anything?
Yep. So I guess the main links will be I'll just post in the chat. So it's the ORML workshop. All the code I've been showed the developer will be available in this repo. And the actual ORML itself. And Acala repository. So those will be the main links. Yeah, that's all the links I can share.
Awesome. All right. I haven't seen any questions come in. So, we'll definitely be hanging out in Discord and chatting, making sure that you guys are, covered on all of this. Bryan, thank you so much for burning the midnight oil with us and doing this extra late workshop. It really speaks to your dedication to our community. So I really enjoyed your talk today, and looking forward to seeing what you cook up next.
Yeah, thanks for inviting. Yeah, yes, happy to contribute into this community and build this ecosystem projects together.
Awesome. Well, sleep well, Bryan. Enjoy your evening.
Yeah. Okay.
Bye-bye.
Bye.